Hello students, my name is Vishal Patel. Welcome to my YouTube channel Philomath. If you like this video, do like, subscribe and hit the like button for the further notifications. Now let's start with the today's topic, probability. Now before you understand what is called as a probability, let us start with a term called as a random experiment. Now what is called as a random experiment? An experiment whose outcomes are already known to us. Like, let's take an example. A die is thrown. Now, before we throw a die, we already know what are the options we'll be getting. Either we'll get 1 or 2 or 3 or 4 or 5 or 6 on the uppermost surface of a die. Okay, so a die is thrown is a random experiment. One more example, a coin is tossed. So when you toss a coin, what are the options we can have, or what are the outcomes we can have? We can have head or a tail. When two coins are tossed, the options what we can have is HH, HT, TH and TT. Now HH means head on the first, head on the second. HT means head on the first and tail on the second. TH means tail on the first and head on the second. And TT means tail on both the coins. Okay. Now let us see what is called as a sample space. Let us take an example. A coin is tossed. So we already know a coin is tossed. There are total two outcomes, H and T. So if you're writing those outcomes in a form of a set, that is called as a sample space. So H comma T, the total outcomes are 2. And remember one thing, sample space is always given by capital S. Next example, two coins are tossed. We know that there are total 4 outcomes. So NS is going to be 4. A die is thrown, total 6 outcomes. So NS equal to 6. Okay. Now, suppose if I want to form a two-digit numbers using the digits 0, 1, 2, 3, 4 without repeating the digits. So what could be the sample space for this? Let's see. Now, first we'll see the numbers which are in red. 0, 1, 0, 2, 0, 3, 0, 4. You cannot call these numbers as a two-digit number because 0 in the tens place means all these four numbers are a single digit number, and the question says that without repeating the digits, so 11, 22, 33 and 44 are not to be calculated. Next, out of all these numbers we have to form a two digit number, okay, without taking these numbers. So if I start with 1, 1 0 is 10, 1 2 is 12, 1 3 is 13 and 1 4 is 14. Then we'll start with 2. I'll get 20, 21, 22, not allowed, 23, 24, then 30, 31, 32, 34, 40, 41, 42, 43, 44, again not allowed, repetition is not allowed. Okay, so total there are 16 outcomes. Now, let us take an example of a two dice. So when I toss two dice, total how many outcomes are there? Let's see. Now I have taken two different dice. One is red in color, another is green in color. Okay. So if I take all the possible outcomes, there are going to be total 36 outcomes. That is 6 into 6. How? Let's see. Now, if I take the number 1 on the first die and 1 on the green die, so I have the first option, that is 1 comma 1. I've written here 1 comma 1. If I take 1 on the red and 2 on the green, I have 1 comma 2. I've written here 1 comma 2. If I take 1 on the red and 3 on the green, I have 1 comma 3, 1 comma 3. Likewise, if I keep on taking all the possible outcomes, the last what I get is 6 on the red and 6 on the green. That is 6 comma 6. That is the last pair what I have written here. So total there are 36 outcomes. Okay. Now let us take an example of cards. Now there are total 52 playing cards in deck of cards, out of which 26 are red in color and 26 are black in color. Out of 26 red cards, we have 13 patterns of heart and 13 of diamonds. From black, we have 13 of clubs and 13 of spade. So 13, 13, 13, 13, total 52 cards. So if I take any one particular pattern, suppose if I'm taking a pattern of spades, now what are those 13 cards? Let's see. Now, these are the 13 cards what you'll find in all the patterns. A, that is called as ace, 2, 3, 4, up to 10. These are called as number cards. And J, Q, K is called as jack, queen, and king. These are called as face cards. Okay. Now, let us understand what is called as a probability. Now, probability, if I say in a very simple word, we call it as chances. Let us take an example to understand this. When I toss a coin, what are the chances of getting ahead? We say that there are 50% chances of getting ahead. Now, what do you mean by 50%? If I convert a 50% in form of a fraction, we do 50 upon 100, that is 1 upon 2. So 1 upon 2 is the probability of getting a head. Same way, what is the probability of getting a tail? It is again 50%. So 50 upon 100, reduce, you will get 1 upon 2. So the probability of getting a tail is half. Okay, let us take an example. You have to find a probability of getting an even number when a die is thrown. So we all know the sample space for a die is thrown, that is 1 to 6. Total outcomes are 6. Now I want only even numbers from these. So if I consider only even numbers, so that event A, you can use any other letter but not S. S is for sample space. So A equal to, in a form of a set, I'm writing 2, 4, 6. So that is 3. NA is 3. So what is that? That is nothing but the required outcomes. So now we are going to study the formula for probability. So what is probability? Probability equals to the number of required outcomes or number of desired outcomes upon the total number of outcomes. So for this particular sum, the total number of outcomes are 6, and out of that, the required outcomes are 3. So it is going to be NA upon NS. That is a formula. 3 upon 6. If I reduce, I'll get 1 upon 2. Let us take one more example. A card is drawn from a pack of well shuffled deck of cards. Means you're talking about playing cards. So total there are how many cards? 52 cards. So NS is going to be 52. In bracket I have written total 52 playing cards. We need to find a probability of getting a king of red color. Okay, now there are total 4 kings, out of which 2 are red and 2 are black. We need only the red ones. So the total number of required outcomes is to how to 1 king of heart and 1 king of diamond. Probability is Na upon Ns, that is the required outcomes upon the total number of outcomes. So we need the required outcomes as 2, and the total outcome is 52, 2 upon 52, and if you reduce it, we'll get 1 upon 26. Thank you so much.